Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're watching us on Zoom, just look at the top of the bottom of your screen, wherever your Zoom controls are. You should see a little button that says Q&A. Click on that, type in your question, hit submit, and I'll get to those at the end of the session. If you're watching along on YouTube, just use the live chat function wherever it happens to be on your screen, and I'll get to those questions at the end as well. So my name is Jason Gabrinas. I'm one of Snap-on's National Diagnostic Technical Trainers. Been in the training department the last, I'm starting my 10th year in the training department now, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep with Snap-ons at about 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, those weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bag. And before that, a bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. Our topic at hand is guided component testing, and we're up to part 3 on guided component testing. So we've covered some of the basics before in other videos, and some of the other functions and how useful guided component testing can be for your diagnostic day. But we have made some improvements very recently, just with the latest software update that just came out. So I'm going to cover some of those tonight, as well as some other features and functions you might not be aware of. So to recap and to kind of bring it back to where we start, diagnostic tools, right? We have 2 different types of diagnostic tools. We have scanners and we have scopes. When I like to think of a scanner, I like to think of it like a compass. It's going to point us in the right direction. It's going to show us where we need to look, where we need to go, but it's really only showing us part of what's going on under the hood. It's showing us the effect after it already happened. Now, for every effect, we need a cause, right? So in order to find that cause, that's where the scope comes in, or in this case, guided component testing, which is a scope that's going to do most of the work for you, which is the beautiful thing of this, because it's going to save you a lot of time and effort and looking up information, because it's all going to be right there for you. So we think of a vehicle's computer. Let's think of it like a house. It's got a front door and it's got a back door. Coming in that front door is going to be all my input signals. So my coolant temp sensor, my NOx sensor, my oxygen sensor, all those inputs go into the computer. Then the computer processes them however it is programmed to do so. And that's the key point right there. It's only as good as its programming, because that's why we have these things called reflashes. So if they made an oops in the programming, you might have to reflash the computer, flash new software onto it, and then it would work properly. So it takes all of that, and then it spits that data stream out the back door and goes to the scan tool. So if I'm only looking at data through the OBD2 port from the scan tool, I'm only looking at that processed data after the computer already had its grubby little hands on it. Now, it's good to have, but it's only, like we see here, it's just half of the equation, because the other half we got over here coming into the computer. Really, the difference is going to be in the details of the signal. How much can I see on the screen looking at the scanner versus looking at using the scope guided component testing? This top part of the window is going to be data, reading an oxygen sensor voltage on a 2006 Chevy Cobalt. This bottom part of the window is the same voltage coming out of the oxygen sensor, just at the oxygen sensor itself, reading it with a scope. And as I think you can see, these red boxes show the same amount of time passing. There's a big difference in those 2 boxes. I think you would agree. If those 2 little dropouts were there, if I was only relying on that scanner data, I wouldn't have seen it. Now, it's not the scanner's fault. It's really more the car's fault in the way it's designed. Because we think about the data has to come in, the voltage has to come in, and then it has to process it, and then it sends it out. Comes in, process, send out. Come in, process, send out. Every time that happens, we lose a little bit of resolution in that scanner data, because the computer has to pause and think and process. So it's not actually truly live data. Folks will call this live data. It's not 100% live. It's at least a few milliseconds old, and it is that processed data after the fact, after the computer got its hands. Still useful, but we just have to remember that we just have to remind ourselves that it's not actually the live data that's coming in. It's been processed already. So when we're using scopes and guided component testing, we're really checking for component failure, because that's going to cause a drivability problem, or that's going to cause a code to happen, or whatever else we're trying to diagnose in this vehicle. It's going to be some sort of a component failure. So we could have, really, I think that falls into 3 different buckets. We could have an open, which would be no voltage to the component. So maybe I need a 5-volt reference signal on this component, and there's a break in the line somewhere. It's not getting the 5 volts. Or we have no voltage coming from the component, and open coming on the output side of the component. So maybe it's supposed to send a signal back, a variable signal back to the computer, and that line is interrupted somehow. So we got no voltage from the component and open that way. Or we could have a short. So say we have an excess voltage, a short to power. Say I got a 5-volt and a 12-volt line rubbing next to each other in the harness, and they're shorting together, and now I have 9 volts or 10 volts going to the component. That's a problem, excess power. Or insufficient voltage. If I have a short to ground somewhere in the system, it could pull down multiple sensors depending on where that short to ground is, shunting the voltage off. Instead of having 5 volts, now I have half a volt. That's definitely a possibility. As well as a resistance problem. If we think about corrosion, especially up where I live, corrosion is a huge problem because of the salt on the roads and whatnot. So we have a problem with corrosion in the connector, that green fuzzy stuff. Or damage. If I have a frayed wire, multi-stranded wire, it's not going to carry nearly as much current as it's designed to if it's frayed, because I only have so many little pieces of wire connected. Now it's going to flow some voltage, and it's going to have maybe the ohm meter might read the same, but it's not going to flow nearly enough current in order to carry a load necessarily. So these are the 3 things we're really looking for when we're component testing. So what is guided component testing? Kind of as a refresher, if you've seen our other videos on this topic before, and if you haven't, then here's your first intro. So what it does is, it is a database, and it's been around since 1992. Goes back to 1981 vehicles, and there's over 5 million different tests inside this part of the tool. So it gives us operation, location, connector views, any tech notes, and anywhere between 1 and 6 different testing methods in order to test the component that we're looking up. Having all this, and it sets it up for you too. It sets the voltage up, sets the time up, and it sets the trigger up. Does all that for you, which will help you test the parts more accurately, which avoids unnecessary parts replacements, which in turn can prevent a comeback. Because if you misdiagnose a part, well, man, that car is probably going to come back. Or what's worse than a comeback is a never comeback. Those are the ones that, well, they didn't fix it right the first time, so let's go give this shop down the street a chance instead. Sometimes people do that. I don't know why they wouldn't just bring it back to the same place at least a couple times, but so it could happen. You could get a never comeback. They go down the street, and in that case, if they fix it down the street, then you may have lost a customer at that. So being able to diagnose it properly is going to prevent that. Also, other side of that coin, if you have that reputation as the shop that fixes it right the first time because you're testing it properly, could help attract new customers. And all of these things all together, doesn't matter who you are in the shop, it's always good to be in a profitable shop. Shop's not profitable, you won't have a job for very long. So it's no matter who you are, the secretary, the owner, or the tech in the shop, having a profitable shop is going to help everybody overall. So guided component test gives us how to hook it up. So if we look at this sample screen here, so we have color-coded wires, right? We have color-coded test leads. So yellow is channel 1. That's going to go to, in this case, cam position signal. And black goes to known good ground. So if I look over here, cam position signals pin A. So we can see where that is over there. And a known good ground. Now, I wouldn't use the ground at the component. I would use a ground at say, the battery. Is best case scenario. You want to go to the best known good ground, not necessarily the ground on the component, because we could have a bad ground at the component too. And that is where to hook it up. And then also, most times, it's going to show you what it should look like or what value you should have on the screen. So in this case, it's a up and down. We can see the little teeth on the cam sensor. So gives you all of that all in one place. I don't have to look it up in separate areas, things like that. Then we go to some improvements that have been made very recently. Now, I got excited when I saw this, when they first showed this to me. So location images. So instead of just having words on the screen that say, okay, it's over here on the left-hand side or the right-hand side or whatever, it's going to actually give you images of where this component is. So in this case, we have an overview of the engine. Overview of the engine compartment there. And it says it's over on this side. And then if we get a closer view here, we can see there's the ABS pump and there's the ABS modules, what that's actually looking for. So I can see where that is. So visually, it's a lot easier to find out where that is. So that's a pretty cool improvement. It's on select vehicles right now. As it moves forward, they'll of course be adding more and more images to this because they actually physically have to be in front of the car to take the pictures. So having that's going to be very helpful. Also, another improvement is these enhanced connector images. So if we look on the left-hand side, that's what they used to look like, right? So we had just these squared off generalized pictures, but they didn't really scale. As we increase the size of the screen, resolution of the screen, we'd want to be able to see these a lot clearer. So now we have these much larger, more modern looking connector views here, which I think would be very helpful. So just make it a little easier to see, especially on those bigger screens that we have now with our higher resolution. So let's look at a couple of these examples and a couple things we can see on the tool. Now, in this case, I'm on a Zeus Plus. We have any of the Zeus, any of the Triton, any of the Modus, any of the Vantage tools will have this guided component test function in there. So anything with a scope, it's going to have this guided component test. And we load in, we can see there is a lot of different vehicles here, right? So we got, all the way from Acura to Volvo, and that's pretty much most of the vehicles we cover on the scanner side. We also cover on this side as well. So the other thing that I like to mention always, and remind you, if you were aware, now you can be more aware. There are built-in classes in here. We always want more training, more training, more training. That's probably why you're here, so you can get more training. But there's also built-in training in the tool. So we go into classes, there are power user tests, for example. And let's say I wanted to do something with a low amp probe, current probe. And go in here. It's going to ask us to select the current probe. We can either do a generic low amp current probe, anybody's probe, the older style red snap-on probe, or the newer style black snap-on probe. And then we can do current ramp testing. And what this will give us is generalized tests. So these are generic, generalized, not vehicle-specific tests. In order to get to the vehicle-specific tests, of course, that would be IDing a vehicle. But we can see we have fuel injectors, fuel pump, ignition coils, and parasitic draw testing, all with this low amp probe. But also note, as I was rooting around in here, refreshing myself on this class, we have low amp probe reference manual. So the actual manual for the low amp probe is in here, and it gives you a lot of different information like auto zero adjustment, battery replacement. That one I need to get reminded of every once in a while because there's a couple different screws and I always seem to pick the wrong screw to unscrew. So that's good to have. Connecting the probe, things like the switches, safety, millivolt scale. This is important as well. So every low amp probe on the market, whether it's a snap-on one or elsewise, going to have a certain conversion factor. So what it does is when it reads the current flow, it converts it to a voltage. Then it sends that voltage out through the probe leads into the scope. And then the scope internally will do the math and do the conversion for you. So that's why you need to set up the scope to say, okay, I'm using low amps 20, low amps 40, what have you. Otherwise, if you're using a non-snap-on low amp probe or say the high amp probe or the medium amp probe that we also have that are not the low amp probe, you would need to use a voltage scale and then just do the math. So in this case, on the 20 amp scale on the snap-on low amp probe, 100 millivolts is an amp. So if I saw 1.8 millivolts, that would read 18 milliamps. If I saw 21.8 millivolts, it's 218 milliamps, and so on and so forth. So 100 millivolts equals 1,000 milliamps of an amp. So having that conversion factor, so I know what it needs to be, because I actually got a call a few weeks ago from a franchisee, and they were wondering about using a high amp probe on a vehicle. They had a customer that worked on a lot of diesels and so on. So they had a lot of battery cables coming off the battery. Low amp probe can't really fit. Plus, it's going to over 100 amp draw. So they wanted to use the high amp probe, and I said, yeah, you absolutely can. You just have to, because it'll plug right into the scope. It's got the same banana jacks there. It'll plug into the scope, but you have to do it on a voltage setting, not a current setting, because the conversion is going to be a little different. So you just have to look at the little pamphlet that comes with it and see what the voltage output per amp is, and then you might just have to do a little bit of that. So put it on volts instead of amps, and you can do it that way. There's also inside here the electrical data, right? So this would be the part of your pamphlet that would have this in there. So it says working voltage and all that. Or how about, for example, maybe I wanted to do some pressure transducer tests, right? So we can go into pressure transducer tests. We can do line pressure, exhaust back pressure, fuel pressures, etc. You can go in there. It's going to tell you how to set that up as well. But the meat and potatoes of this training, these training classes, are going to be in the how-to section. So there are 65 different categories of classes. So anything from let's see. So it starts at 10-minute basic electronics class all the way down to 20-minute current ramp classes. Right? We have oxygen sensors, electrical theory, general test procedures, advanced component descriptions, 20-minute smart charge class. All right, let's look at that. Smart charge calculation. So many vehicles manufacturers today are investigating the implementation of smart charging technology. There's many limitations associated with conventional charging systems. Main issue is the ability of the battery to accept the charge from the alternators, depending on electrolyte temperature, and et cetera, et cetera. I'm not going to read through the whole thing, but you can see this is going to talk about variable charging systems. Brushless DC motor class. So it's going to talk about brushless fuel pumps, which you're actually going to refer to here in a little bit, or just brushless DC motors in general, which would be the fuel pump also does that. Spark ignition induction. NOx emissions, etc. There's a whole lot of information in here that you can look up at any time. If you have one of these tools, you don't have to ID a car, don't have to hook up to a car. These are all generalized classes that'll work on anything. I think that's very helpful. Very helpful. All right, so now let's pull up some of the vehicle information. So I'm going to pull up a 15 Subaru Legacy from back in my day. And I'm going to go into guided component tests here, right? That's what we're talking about. And then you see quite a few different categories. So let me back up for those of you not familiar. So this is vehicle-specific information. I just ID'd a vehicle from my history. And once I do ID a vehicle, the first thing that's going to list is all the systems we have component information on this vehicle. So 1, 2, 3, 4, 5, 6, 7, 8 different systems on this vehicle. I think we're up to 12 total systems that we cover just throughout, depending on the vehicle. But in this case, I'm going to look at engine. And let's say, you can't necessarily memorize every component on every car that you work. Maybe you work on different cars every day. Work on the same car every day, maybe, yeah. But in this case, let's say, I wanted to find out where's the oil temperature sensor on this vehicle. So I can go into oil temperature sensor, and then you see we have that location image, that new location image there. And then we see there is my view of the engine compartment. It's pointing at the oil filter. And then if I look closely at the oil filter, there's my oil temperature switch right below it. It's easy enough. It's going to show me that component location. So that's helpful. And like I said, that's not on every vehicle and it's not on every component, just because that's a gargantuan undertaking to do. So they're going to do on the more common cars, or the cars they're able to get a hold of in order to do that. And as we expand this, it'll be expanding to older vehicles or other vehicles that it may apply to as well. So look for this to grow over the coming. Next one I want to do is going to be the connector view. So updated connector views as well. So I'd shown that a little bit earlier. So let's say I wanted to look at something like the ignition coil. Current ramp test. I think it's in there. Might not be in there. Yeah, So we have a couple different connector views, and you can see they're much larger than they were previously. So we have the 3 pins right there. It's going to tell us for the coil. And then this is a 6-pin connector here, A through F. So that's your each individual cylinders. And then down here we have the current ramp pattern that we would be seeing looking at a current ramp test on a coil. So those are our new connector views, makes it a lot easier to see. And what else do we want to do? Oh yeah, another big change that has been very recent is on a lot of electric and hybrid vehicles. So in this case, the 2016 Nissan Leaf, there is a whole new section in here for high voltage electronics. So if you have a hybrid, a mild hybrid, or a full electric vehicle, especially they made a big focus on the Leaf this time. So anything 11 to 21, 2011 to 2021 has all these new HV electronics. So things like the high voltage coolant temp sensor, vehicle service plug, quick charge port, traction motor inverter. Right, so we have different tests that we can do there. Back up. Let's see about the traction motor in general. We can see about, what is it? There's different resolvers on there, which is kind of like an encoder to see where that is in rotation. The traction motor contains an interior permanent magnet synchronous motor. Permanent magnet is embedded inside the rotor core, and the rotating magnetic field generated by the stator coil is used to generate rotational torque. Traction motor is able to generate torque even when the vehicle is stopped and outputs maximum drive torque when the vehicle starts moving in order to provide good initial acceleration. And that is one of the beauties of an electric motor is it's pretty much instantaneous torque. As soon as you hit go, it'll go. Now, as we can see, it's a 3-phase motor, right? So we have U, V, and W. Also gives us a procedure on how to disconnect the high voltage, lots of warnings there, things that you want to read and be aware of before you would go and work on one of these vehicles. But a lot of information in there. And actually we could do, let me go back to that, resistance test. So we can do a resistance test between the different terminals here on the main plug. So we can see, whether or not we have an issue inside internal the motor. Right, so it should be between 1 and 8, 20 to 35 ohms, 8 to 15 ohms, 20 to 35 ohms. So it's going to, we have to wait 10 minutes, pull out the plug, etc. So there's some safety stuff that needs to be done, but all this information is in there and it's readily available for you. So I think that is a pretty good ad because these vehicles, they're out there, especially like this Nissan Leaf, right? So it started in 2011. So those are definitely coming into shops now. That's a 12-year-old car, 12-year-old car at that. So they're definitely coming into shops. And if you're picking up this extra work, you'll have that information available to you right in there. Then the last thing I want to talk about is another, I think, pretty cool ad. So on BMWs, Minis, and Mercedes, this go around anyways, we added information on brushless fuel pumps. So if you're used to looking at fuel pumps, the old brushed style fuel pumps, they're a little bit different. Actually, they're a lot a bit different than these brushless motors. But if I come into the pump and I go to component operation, let's see, fuel pump contains a check valve, electronic fuel is 3-phase brushless motor. The DME or ECM controls the fuel pump via pulse width modulated signal from the DME. Electric fuel pump is a brushless 3-phase motor. The fuel pump control electronics activates the 3-phase motor. Pulse width modulated signal is also used for diagnosis of the fuel pump control electronics. So depending on how that signal goes, it can diagnose the system. The 3 phases that operate the fuel pump are as follows: phase U, phase V, and phase W. Each phase is pulsed for 120 degrees of rotation. In the event of the crash, the fuel pump is disabled. So we need to come down here. We need to go into the fuel pump electronics, or the ECM. The system does not use a fuel pump relay. Fuel pump is controlled with its operating voltage from the fuel pump control electronics, which receives its signal from the ECM. Fuel pump control electronics activates the brushless 3-phase motor. Fuel pump control electronics is not a control module and is not the same as the EKPS module. Do not attempt to activate this brushless 3-phase fuel pump with a system voltage, or the pump will be damaged. So don't use power probe or whatever. Do not apply voltage directly to the motor, because that will be a really bad idea. All right? Bad idea. And then if we wanted to do, say, a current ramp test on this. So this is actually got quite a bit of good information in. Each of the signals is 120 degrees apart for a total of 360 degrees. By adding each of the three signals at 120 degrees, you can see one fuel pump revolution. Current polarity is a must to correctly view each of these signals. You can tell the current probe is correct because of when clean square waveform begins to modulate, the current should begin to ramp up at the same time. Current ramp waveform is inverted. Try flipping the current probe 180 degrees. That's true if it is inverted, but it is going to be inverted at some point because there is a positive side and there is a negative side. So you'll get it switches polarity back and forth between the coils. So you'll see a positive current ramp, no current, negative current ramp, no current, positive current ramp. So you see up and down. This is a pretty good approximation of that. It looks a little different on the Toyota I was used to seeing, but you can see how that goes. You can see the different phases there and see how they line up. One goes positive, one goes negative, and so on and so forth. So a lot of good information in there on these new brushless fuel pumps. And as I said, on BMW, Mercedes, and Mini, that is in the latest software update. I'm sure other manufacturers will be coming in as we go as well, because I know Toyota uses it on a bunch of theirs. Honda's starting to use it. So they are out there, and they do test completely different than what we consider a regular or brushed fuel pump that we've been used to for all these years. Lots of good information in there. All your pin assignments and all that. Hopefully we got a little bit more information on guided component tests and what it can do for us within the tool. And as I said, if you have one of those tools with the guided component test function, there's a lot of information in there, and you do not have to hook up to a car to get it. You can just go into the database and look and see, what can I do on this vehicle? What ways can I test it? What different components are there? Learn about how those components work so you can test them properly. So that is my time for today. Let's talk about what we're going to talk about next week. And it's related. It is definitely related. So next week, we're going to cover testing intermittent electrical faults. We'll talk about those pesky intermittent problems, talk about different circuit layouts and how we might test it using triggers on the scope and things of that nature. So make sure you join me again next time, same time as next week, same time and same place. 6 and 9 Eastern. If you want to join on Zoom at snapon.com/OT, you can go there to reserve your spot. Otherwise, the 6 p.m. Eastern class goes live to my YouTube channel like we're doing right now, youtube.com/Snap-on Diagnostics, all one word. Or 9 p.m. goes to Facebook. So if on my Facebook page, you want to give me a follow over there, it's facebook.com/SnapOnJason. If you're watching on YouTube, please make sure you give me a like and a follow, and subscribe to the channel and ring that bell as well, just to make sure that the algorithm plays nice. Also, if you want to catch any of the previous topics in this live stream series, anyway from ADAS to 48-volt mild hybrid systems, they're all available on our YouTube channel. Once again, youtube.com/Snap-on Diagnostics. There is a playlist for live training on there. You can go check those out anytime, 24 hours a day, 7 days a week. Make sure you check that out. Now it's time for questions, but before I get there, I also want to make sure that you are aware that my buddy Keith also does live training every Wednesday and Thursday night. So on Wednesday, it's on Zeus Plus, and on Thursday, it is on Apollo and Triton kind of combined, because the scanner functions are very similar between those two tools. So 7:30 Eastern, 6:30 Central, he does it one time a night. So go to snapon.com/OT. It is Zoom only. If you go to snapon.com/OT, check that out. Make sure you watch my brother Keith go and take you through very comprehensive training on either of those tools. They're both about 2 hours long. First hour is going to be on setup and scanner functions. Second part is going to be on scope and meter functions. So definitely worth your time there. All right, let's get to questions and comments. If you are watching on Zoom and you do have a question, just hit the Q&A button. Type it in there. Let's go over to YouTube. Got a few comments today. Peter says hello. Mauricio says ciao. Must be from Italy. That's a wonderful thing. The Winton, hello, welcome. Thanks for joining as usual. Quinn, welcome. Says, sheesh, where is this when I was looking through those thick F body and W body shop manuals? Yeah. So I don't know. I mean, like I said, it's been around since the 90s, but not as widespread as it is now. So definitely, it just keeps getting better with time, better with age, like fine wine. That's right. Nick from the UK, thank you for joining again. Can't wait for next week's training. So thanks a lot. Olu says, thank you. Anthony says, great production today. Best sequel out there. Yeah, it's a threequel, right? So it is the end of a trilogy. Maybe we can have 4. I don't know. We'll see what else we can talk about. Olu once again says, it's a good improvement. It's interesting seeing all the improvements with the guided component test. Yep, for sure. And the Winton says, thank you again. Enjoy the weekend. 86 Azarate says, oops, I'm late, but that's okay. You can always watch the replay. Or since we're still live right at the moment, you could probably rewind it all the way back to the beginning. I think you can do that. If not, just wait for the replay. You'll be back in a little bit. With that, I think that covers everybody and all questions and comments. So I'd like to take a moment to thank everybody for spending a little bit of time with me. Hopefully we learned a little bit more about guided component testing, the improvements that have recently been made, and how it can help you in your diagnostic day, because it sets up all the functions for you, all the information right there, right on the screen. Makes it really easy. Let's see. Nick is asking a question. Let's see. Replace your brake pads on a 22 Renault. Snap-on Zeus can do it. Not sure if it can do it or not, because I do not, unfortunately, have UK software over here. We don't have Renault in the US softwares. Not sure. Might want to call the tech line over there and see what they have to say. Sorry, I couldn't help you on that. Anyways, with that, thank you very much. Hopefully you can see me next week for testing intermittent electrical problems. Enjoy the rest of your week. Enjoy the weekend. Have a great night and take care.